presentation of them all. We hope you enjoy. Hello, my name is Aaron.
My name is Songwa, and my name is Taejun.
And we are Team Skibidi from Seoul, Korea. Our topic for the presentation is, can urine replace urea water for diesel cars? So to start off, what is urea and urea water? Urea is a colorless compound made from protein digestion and can be found in mammalian urine. Urea plus pure water makes urea water, which is essential in operating diesel engines. These are the molecular structures of urea and urea water. Then, why is urea water important in diesel engines? Diesel engines produce various harmful gases like carbon dioxide and methane gas. But these gases made global warming and ozone destruction. Therefore, all the diesel engines made after the year 2000 are required to have a catalytic converter. And urea water, as shown in the picture here, helps filter the harmful gases into harmless nitrogen and water vapor.
In 2022, Korea suffered a severe urea water shortage, which threatened to halt energy and transport industries. Due to trade issues with China, from which Korea imported most of its urea water supplies, Korea was faced with serious urea water shortage, making it impossible for large vehicles such as ambulances, delivery trucks, and ships with diesel engines to go anywhere. This crisis made us wonder, is there an easier way to procure urea solution rather than depending on other imports from other countries? As Aaron mentioned in first page, urea is a byproduct of protein metabolism and found in urine. So we wondered, first, does human urine contain urea? Second, what are the similarities and differences between urine and urea? And finally, third, can we extract pure urea out of human urine? If we can answer these questions, we can answer whether we can replace urea water with urine for diesel cars.
A simple urine test we get at routine hospital checkups shows the composition of urine. You can see on the slide that such analysis shows that urine consists of 96% of water, 2% of impurities, and 2% of urea. Although 2% sounds minimal, if you disregard the water portion, it still makes up the half of the remaining composition. We conducted a simple experiment which can determine whether urea exists in urine and also the similarities and the differences between urine and urea water. We found out that when urea is mixed with bean juice, the urea decomposes and turns into base. And this phenomenon will determine whether urine contains urea or not. We reproduced the high school chemistry experiment which checks this phenomenon. Lab supplies included urea, urine, distilled water, BTP solution, a pH indicator, which I will talk about a bit later, and bean juice.
And I'll explain the procedures of the experiment. First, you prepare 30 milliliters of distilled water, urea solution, and urine, and put them in a beaker. Then, you add 1 milliliter of BTP solution and observe the color change. And this was our control experiment. In the second experiment, you add distilled water, urea solution, and urine mixed with 20 milliliters of soybean juice. Then, you add 1 milliliter of BTP solution and observe the color change. Then, how can we know whether the solution is acid or base? As Taejun mentioned before, BTP solution is a pH indicator which determines the pH through color changes. pH ranges from 0 to 14, with 7 being neutral. Less than 7 is acidic, and more than 7 is basic. When we put our BTP solution, we observed the colors and compared it to the color map on the screen.
Now let's look at the results of the experiment together. At first, the solution without the bean juice, distilled water is pH 6.0, urea is pH 7.1, and urine is pH 6.7. Now the solutions that contain bean juice shows a bit different result. Distilled water became pH 6.2 from pH 6.0, which is less acidic. Urea became pH 8.0 from pH 7.1, which is more basic. Similarly, urine became pH 7.1 from pH 6.7, which is more basic. Even though bean juice is acidic, urine with bean juice became much more basic.
Now, let's discuss the results. How does this experiment show that urine contains urea? Soybeans contain urease, an enzyme that breaks down urea into ammonia and carbon dioxide. When urease meets with urea gives up ammonia and carbon dioxide by the chemical reaction with water. Since ammonia is base, both the urea solution and urine turn basic and into a darker color.
Now, what are the similarities and differences between urea and urine? The similarities are that they both contain urea and water, and the differences can be shown when you have BTB solution and bean juice. Before, urea solution turned into a darker color, meaning that it's more basic. This can be because urine contains other impurities such as urea, creatinine, uric acid, and more, which could have made urine more acidic.
Now that we have seen that urine has urea and urine and urea both have similar properties, we now move on to answering the question of removing urea from urine. For this, we propose a 4-step procedure. First, you boil the urine and reduce its volume. Second, you add methanol, then separate the methanol layer. Third, you add sodium hydroxide. Last, you add sulfuric acid or hydrogen chloride. And finally, you will be left with pure urea.
Of course, there are some limitations to our study. For example, the experiment could check that urine contains urea, but not each concentration. Also, the pH was estimated by the human naked eye, not a machine, and we couldn't check if other impurities were present that could change the results. Also, the experiment environment may not have been perfectly clean, so there might have been possible experimental errors.
So, in conclusion, can we use urine in diesel cars? Theoretically, it's possible because both urea solution and urine contains urea. And to do this, we can use the proposed method to extract urea from urine. However, it is not so practical. Urine has many impurities. Urea extraction process needs over 4 steps and a huge cost. Also, there is a chance of a car breaking down. So, should we stop trying?
No.
We believe that young scientists like us should keep trying and find cost-effective and safe ways so that countries such as Korea would no longer have to suffer shortage issues. Thank you so much for your attention. If you have any questions, please feel free to ask.
And these were our references to our study. Thank you.